In this video, we're going to talk about triangles. We're going to be talking about two major points when it comes to triangles. We're going to be talking about angles in triangles and types of triangles, how to classify triangles. So first of all, what is a triangle? A triangle is three line segments that intersect only at their endpoints, like the picture shown, and each side of the triangle is considered a line segment, which is a line that has two endpoints. And each one of these corners where these line segments intersect is called a vertex. Just like we talked about with angles, the place where these two line segments come together is called the vertex. And then we create three sides and also three interior angles. So every triangle has three sides and three angles. The angles of a triangle all add up to 180 degrees. This is called the angle sum theorem. All three angles in a triangle add up to 180 degrees. So in our example here, angle X plus angle Y plus angle Z will always add up to 180 degrees. So how does that help us find missing angles in a triangle? Well, if we look at this example here, we see that we know two angles of the triangle, but the third one is missing. Well, what do we know about the angles in a triangle? We just heard that they add up to 180 degrees. So I know that 89 degrees plus 54 degrees plus X degrees must be 180 degrees. So I know the other two angles have a sum of 143 degrees. So what does that leave us to get 180 degrees? 37 degrees. So my missing angle has to be 37 degrees. So that's one way we can apply what we know about angle sums in triangles. We know that they all must add up to 180 degrees. That helps us find missing angles in triangles. Here we know the measures of the angles of a triangle are in a ratio of 1 to 3 to 6. And what are the measures of the three angles? Well, this one's a little bit more difficult for 7th graders at times because we struggle with ratios a little bit. But what does that ratio tell us about the angles in our triangle? Well, it describes the three angles. So we can think of this one here as angle 1, this one is angle 2, and this one is angle 3. These are the three angles, and this is the ratio that they are. That means if angle 1 is 1, that means angle 2 is 3 times bigger than angle 1, and angle 3 is 6 times bigger than angle 1. So those are the things that we know. So if we just call angle 1 X, we don't know how many degrees it is. We know that angle 2 is 3 times bigger than X, so that would be 3X. And we know that angle 3 is 6 times bigger than angle 1, so that would be 6 times X. So now we know kind of how all these angles are related to one another. So I also know that they add up to 180 degrees. Now I can write an equation. So I know that angle 1 plus angle 2 plus angle 3 is 180. And I know that angle 1 is X. I know angle 2 is 3X. And I know angle 3 is 6X. And they must add up to 180 degrees. Well, I can simplify this to 10X equals 180. And that means X equals 18. So now I know what angle 1 is. Angle 1 is 18 degrees. And if angle 1 is 18 degrees, I know angle 2 is 3 times bigger, and 3 times 18 is 54 degrees. And I know that angle 3 is 6 times bigger than angle 1, so that would be 108 degrees. And if you double check that, all three of these angles do add up to 180 degrees. So that's, again, how we can use the angle sum and ratios to find the angles in a triangle. Next, we're going to talk about exterior angles, and these are angles that are formed by extending one side of a triangle. So if you just take a side of a triangle and make it a little bit longer, you create another angle. So you can see that we have three exterior angles created when we extend the sides of our triangle. Well, when you extend the side, you're still extending a straight line. So I know that the interior angle plus its exterior angle are going to be supplementary. They're going to add up to 180 degrees as well. So in this diagram, angle 1 plus angle 4 is going to be 180 degrees. Angle 2 plus angle 6 is going to be 180 degrees. And angle 3 plus angle 5 is going to be 180 degrees. Well, that's all well and good. And how does that help us? Well, if we remember our angle sum, I know that angle 1 plus angle 2 plus angle 3 is 180 degrees as well. So let's investigate that a little bit closer. So if angle 1 plus angle 4 equals 180 degrees, right here, and I know that 1 plus 2 plus 3 equals 180 degrees, we can conclude that angle 2 plus angle 3 equals angle 4. Now let me diagram that for you a little bit better. Think about this now. If I add 2 and 3 together plus 1, I get 180 degrees. And if I add 1 and 4 together, I get 180 degrees. So therefore, angle 2 plus angle 3 has to equal angle 4. So now we can use exterior angles as well to help us solve for missing angles in triangles. So we also know that angle 1 plus angle 3 has to equal angle 6. Angle 1 and angle 3 together will equal angle 6. So basically it's the two opposite angles together will equal that exterior angle. And then we also know that angle 1 plus angle 2 will equal angle 5. So the two interior angles that are not part of that exterior angle will add up to equal that exterior angle. So how can that help us solve a problem like this? There are actually two ways to find the value of x in this problem. The first one being pretty straightforward. We can figure out what this angle is, and then I know that all three of those angles have to add up to 180 degrees. So we'll do that first. I know that 142 plus that missing angle is 180 degrees. So that tells me that that missing angle is 38 degrees. So now I know that this is 38 degrees. Now I know that x plus 95 plus 38 equals 180 degrees. And then these two angles together are 133. So x plus 133 equals 180 degrees. And then that tells me that x is 47 degrees. So x is 47 degrees. Or I know that these two angles must add up to equal that one exterior angle. They are the two opposite angles that are not included in that exterior angle. So I also know that x plus 95 degrees has to equal 142. And if you solve that, x equals 47 degrees. Pretty fast way to solve for that missing angle if I know one of the exterior angles. So two methods to solve that, either using what we know about the three interior angles adding up to 180 degrees, or the two opposite angles adding together to equal one of the exterior angles. So two ways to solve that problem. So that's all we're going to talk about when it comes to the angles in a triangle. Now we're going to talk about how to classify a triangle or how to name a triangle. There are many different types of triangles. So we've got a word here, congruent. We've mentioned that before. And congruent means having the same measure or equal. So we can classify triangles in two major ways. We can classify them by their angles, or we can classify them by their sides. So the three ways to classify a triangle by its angles are as follows. You can have what's called an acute triangle, and an acute triangle is a triangle that has all acute angles. Every angle inside is acute. All interior angles are acute. We can have an obtuse triangle. That's where one of the angles is obtuse, the other two are acute. Or we could have a right triangle. That's where one of the angles is a right angle or a 90-degree angle. Or we can classify triangles by its sides. And by sides, we would look for congruent sides. A triangle that has no congruent sides is called scalene. A triangle that has two equal sides or two congruent sides is called isosceles. And these red tick marks here tell you which sides are congruent. So when you see those marks on a triangle or any other polygon for that matter, it tells you that those two sides are congruent or the same length. And then finally, we can have the equilateral triangle, and that's a triangle that has all equal sides. So we can have combinations of these types of triangles. And so here is a list of all the possible triangles you could ever create. Every triangle you ever draw will fit into one of these 7 types of triangles. There are 3 types of scalene triangles, 3 types of isosceles triangles, and only 1 type of equilateral triangle. So you can have an acute scalene triangle, a right scalene triangle, or an obtuse scalene triangle. You can have an acute isosceles triangle, a right isosceles triangle, or a obtuse isosceles triangle. And you can have an acute equilateral triangle or just an equilateral triangle, since that's the only type of equilateral triangle you can have is acute. So it's kind of redundant to say acute equilateral. So that means there are 2 impossible triangles. A triangle you can never draw is an obtuse equilateral triangle. It is impossible to draw an equilateral triangle that has an obtuse angle. At least 2-dimensionally it is impossible. And a right equilateral triangle. You cannot draw an equilateral triangle with a right angle in it. Again, at least not 2-dimensionally. So let's look at these triangles and classify them by its angles and its sides. So we're going to give it 2 names. So looking at this triangle here, we're going to classify it by its angles, and they're all acute. So this is an acute triangle. And then we're going to classify it by its sides. And notice there are no congruent sides. So this is scalene. So we would call this an acute scalene triangle. Next, all the sides are congruent. All the angles are acute. This is an equilateral triangle. And I don't really have to call it acute equilateral because, as we just mentioned, there's only 1 type of equilateral triangle, and that's acute. So it's kind of redundant to say that. The third one has a right angle in it. So this is a right triangle. And none of the sides are congruent. So this is also scalene. So this is a right scalene triangle. And then the last triangle here, we have an obtuse angle. So this is an obtuse triangle. And it has 2 sides that are congruent. So it is isosceles. So we would say this is an obtuse isosceles triangle. So that is what we're talking about when we're talking about triangles today. Types of triangles and angles within triangles.